Okay, here's another video, guys, for our second Blizzard Bag Day. This video may be useful if we do have school on Tuesday as well, to show you how to evaluate sinusoids. Now, this assignment, evaluation of sinusoids day 1, is in your assignment sheet packet that I've given you. And what I'd like to do is do the first problem, and then if we don't have school, then try the second problem for homework. Okay, take a look at the problem. Here are the instructions. Find the given function value and find the first 3 positive values of x for the given values of f of x. One of these questions is very easy, and it's the first one. Find f of 7.8. This is our first one right here. Well, to do that, all they want us to do is put 7.8 in for x and actually get the value. Now, if I go to my calculator, I already have this typed in F1. So because you'll want to graph these for the other part of the problem. So maybe getting its graph should be the first thing you do, and then you can just go f of 7.8 and go ahead and figure out that answer, and that's what we have. I'll put that in my notes. Okay, 2.314. When we get these values, we'll always round it 3 places. Okay, pretty easy, huh? To get that value, plug that in. All right, it's this next one. Find the first 3 positive values of x. All right, as you can tell in this problem, we need to take the whole function and put it equal to 6. Now, first off, let's do this. Let's say 6 equals the function. There really is a parentheses here. And let's do some algebra work first. What we're going to do first is go about the business of finding, as soon as I can get my smartboard to work here. We're going to get this x right here by itself. Okay? So you can see that x is deep inside the problem. Let's take this a step at a time. Let's subtract 2 from both sides first. How about divide both sides by 5? And then we'll take the inverse cosine. We won't do anything about that just yet. Let's get x by itself first. All right, now let's multiply both sides by the reciprocal of pi over 10, which would be 10 over pi. And finally, let's add 3 to both sides. Okay, now I have x all the way by itself. Now, this will be a kind of a unique problem for us here, guys. This part right here is actually 2 formulas that had to do with the videos that I did previously for inverse cosine. So that yellow part right there is going to be 2 formulas, and so there's actually going to be 2 solutions to this problem. Okay, let's split it up into 2. Okay, so using the 2 formula approach, okay, we'll have 3 plus 10 over pi. Now, in parentheses here, I'll have the calculator answer plus 2 pi n. The calculator answer for the inverse cosine of 4/5 is 0.6435 plus 2 pi n. Now, let's go ahead and work out the complete formula for this. We're going to do distributive property here, guys. We're going to take that 10 over pi and multiply that by both things in the parentheses. Now, 10 over pi times this winds up being 2.0483. Okay, then 10 over pi times 2 pi n winds up to be 20n. Now, these two numbers right here I can add together. That'll wind up being 5.0483 plus 20n. Okay, there's our first formula to help us get the first three positive values. The second formula will be 3 plus 10 over pi. Now, this time, what I'll do to get my formula on the inside here, this number that I'm going to write is 2 pi minus the calculator answer plus 2 pi n. So, the calculator answer, if you remember, is this number right here. So I'm going to go 2 pi minus that calculator answer, and I'm going to write it right here in the parentheses. I did that in my calculator and get 5.6397 plus 2 pi n. Now, let's do the distributive property again with this 10 over pi. We're going to take it times this number, and then we're going to take it times this as well and write it again. So that's 3 plus, 10 over pi times 5.6397 winds up being 17.9517. And 10 over pi times 2 pi n is 20n. Now, I can add these two numbers together again. That'll wind up being 20.9517 plus 20n. Okay, so I got this down to two formulas. Now, let's find the first three positive answers. Okay, now the way you do this is you plug in integers for n. Now, the integers I usually try to plug in is n equals -2, n equals -1, n equals 0, n equals 1. Usually those integer values for n will yield me a positive result. All right, first off, let's try n equals -2. If I put that in for n right here, and I put that in for n right here, if I put this in for n and this one over here, I'll have -20 plus this number right here. That's not going to yield a positive result. If I put -2 in for this n right here and plug it into this, that won't yield a positive result. So let's try n equals -1. We'll try that next. If I put n equals -1 in this first formula over here, I'll have -20 plus this 5. That's not a positive result. If I'll put n equals -1 in this, I'll have -20 plus this number. So I believe that barely gives me a positive result. That will wind up being 0.9517. All right, our next one that we'll try is n equals 0. Let's put it in this formula right here. Oh, if n equals 0, this will go away, and I'll wind up with this number right here. So n equals 0 leads us to 5.0483. And if I put n equals 0 in this, I'll wind up with 20.9517. Okay, so our first three positive answers look like this right here. Okay, there's a way to check this by graphing if you saw that. Okay, if I go to my calculator and I take a look at the graph of this problem, okay, and I put in my original value 6 for f of x. So I'll tab this and put it equal to 6. All right, and then let's find the intersections of this. Of this line in this graph. And I take a look at see what I've got for my intersections. Okay. Hey, that was my calculator answer right there, wasn't it? And then this answer right here was 2 pi 2 pi minus the calculator answer. And then my next positive answer was this one right here. Now, to do this by graphing, what you need to be careful of is make sure you get the graph of the equation. Okay. Notice I did this between -3 and 7. That's because we had a sinusoidal axis, I believe, of this of 2 and an amplitude of 5. That's how I got my numbers right here. And how I got my number right here to go 0 to 40. The period of this problem was 20, and I did 2 periods of this problem. All right, you guys, thanks for listening. Let's try number 2 in your assignment sheet for evaluation of sinusoids day 1, and hopefully I'll see you tomorrow. Thanks for listening.